Okay, good evening, geometry students. I appreciate you finding time to get your notes taken care of. Tonight's notes for Wednesday's class are covering exploring polygons. So let's get started. Our objective for this evening will be the student will learn the basic categorical names for polygons. Again, you're going to see a lot of review, some things that you've known from the past. Okay, but copy down your objective, and as I said, this is for Wednesday's class, so your date is October the 30th. As always, anytime you need more time, press pause and then hit play when you're ready to move on. Okay, now I mentioned this definition today in class, okay, but here you have it for your paper. A polygon is basically a fancy word that simply means an enclosed figure that is composed entirely of line segments. The majority of our time this year is going to be spent focusing on polygons. We will look at some shapes that are not polygons, but there are not many of them, okay, but we'll get to that later on in the year. Okay, so just generically speaking, okay, a polygon can be anything. That if it's built out of line segments, this can include figures that we are familiar with, like the rectangle on the left, or the trapezoid there in the left middle, or the triangle there on the right middle. But basically, the sky is the limit as far as polygons go. You can, as you can imagine, you can come up with some pretty creative things that would still fit into the category of being a polygon. Okay, so basically the flip side of being a polygon would be you are not allowed to have any openings, okay, towards the inside of a figure, okay, such as that shape over there on the right side. Okay, it can't just be an open gap in the wall like that. And it also excludes the possibility of a figure having any curved surfaces. Okay, so one of the obvious ones that is taken out of the possibility of being a polygon is a circle. Circle is a special kind of shape that is not built out of line segments. We'll study it later on this year. Okay. Now, from the different types of polygons, our polygons will fit basically into two basic categories. Okay, one of these categories we will spend pretty much all of our time looking at. The other one, not nearly at all, but you'll need to know the definition just the same. Okay, so our two basic types of categories, the first one is called convex. You may have heard this term through some of your scientific discussions over the years. And I don't really have so much of a definition as I do a description for you. Actually, a couple of descriptions. Convex, basically, if you trace the perimeter of a convex polygon, each vertex basically turns the same direction. And I'll show you what I mean by that here in just a second. And another way of thinking about the idea of a convex polygon is obviously it's not going to be round, okay, but a convex polygon is round-ish, okay, in appearance. And again, I'll explain that further in here in just a second. Okay, here are three examples of convex polygons. Okay, and if you look at the two basic definitions or descriptions there, okay, you get the idea. Okay, if you started traveling like around this red square, this red diamond looking guy on the left hand side, if you started at 12 o'clock and started traveling down the right hand side, when you reached the next corner, you would have to turn right in order to continue along the perimeter of the polygon. Then when you reach the vertex down at the bottom, again, you would have to turn right to stay along the perimeter. When you get to the corner, the vertex at the left side, again, you would have to turn right. So as you travel around a convex polygon, you actually have to turn the exact same direction at each corner. Okay, so that's part of the description of being convex. And I always kind of thought of it like this. In the Flintstones world, convex would be their idea of what is round. And of course, you know, in the Flintstones, nothing is round. Everything's all jagged and edged and stuff like that because it's carved out of stone. So these three polygons here are convex, but these might be something like Fred Flintstone would have on the tires of his car, kind of round-ish. It would try to roll, okay, but it wouldn't be a smooth ride. Anyway, that's a convex polygon. The flip side of that discussion is concave. Okay, and for concave, not all of your vertices are going to turn in the same direction. Okay, many of them may try to turn in the same direction, but there will be at least one location that will try to turn the opposite direction on concave. And an easy way to remember concave is that it has at least one side that looks like, appears to be caved in toward the center of the polygon. And I gave you some examples of concave polygons there. Okay, like the star. If you start at the top of the star, travel down the right side of that top peak. When you get to the first vertex, you have to turn left. Okay, well and good. So as you travel along the right arm of the star and get to the next vertex, you'd have to turn to the right. So I think I said that backwards. First turn would be left, the next turn would be right, and then again, when you get to the next vertex, it turns left, it turns right, it turns left, it turns right. So you're not turning the same direction at every corner. Okay, so that is part of being concave. And as you can see on these shapes, there's at least one spot where the vertex is actually pointing inward towards the center of the polygon rather than outward. So that is concave. That's our two basic categories for polygons, and we will spend pretty much the bulk, if not the entirety of our time working with convex polygons and very little time working on concave, but you need those definitions just in case those terms ever pop up. All right, now our polygons can be further classified based upon their numbers of sides, and we'll get to that here in a moment. Okay, but there is a more technical definition for the idea of concave and convex. So let's take a look at this. This involves what is called a diagonal. Okay, so a more specific way we can categorize polygons into being concave or convex, and it deals with diagonals. A diagonal is a line segment that connects non-consecutive vertices of a polygon. This is probably a new term for us, okay, and it's going to be a confusing one because it does not mean in geometry what it means in the English language. Diagonal in the English language means not horizontal and not vertical. Okay, diagonal in geometry doesn't have anything to do with that. What a diagonal does is it connects non-consecutive vertices in a polygon. Okay, so if we were to draw in the diagonals of a couple of shapes here, okay, well I started off with a six-sided polygon. We're going to talk about that here in a minute. It's called a hexagon. If you were to draw in all of the diagonals, those are all of the red lines that are inside of the figure there. And as you can see, there are a lot. Okay, but the important thing is to notice is that all of the diagonals inside of the figure, or all the diagonals for the polygon, none of them occur outside of the figure. They are all contained within it. And when that happens, that is a characteristic of a convex hexagon, convex polygon. In this case, it's a hexagon. Okay, all of the diagonals contained inside of it. On the other hand, if we look at a concave polygon and start connecting the diagonals, you can see we end up with a bunch of stuff inside of the figure, inside of the this decagon, as it turned out, 10-sided polygon. Okay, but you can see that we have diagonals that are traveling outside of the polygon. Okay, that is part of being concave. We have diagonals outside of the polygon. Okay, so it's nice to know the little descriptions and things like that for concave and convex, but you can't rely just on my silly little descriptions. You got to know the textbook definition as well. Okay, and the textbook definition is that none of the diagonals get outside of the polygon. Okay, let's move on. Let's look at the basic categories as far as the numbers of sides of the polygon. Going to go quickly through this because I think you're familiar with the majority of these. Okay, first off, we've already talked about our three-sided polygon. Three-sided polygon, obviously, is our triangle. Okay, no mystery there. We are going to spend a good bit of time this year talking about these next guys. Okay, what is the term that goes along with a four-sided polygon? There's a lot of them, and we're going to be spending a lot of time working on them. Okay, the generic term for a four-sided polygon is quadrilateral. Okay, the prefix quad meaning four, and again, lateral means away from the middle. Those are the sides. Okay. You probably already are aware, what do we call a five-sided polygon? Okay, most people are familiar with this one because of our capital in Washington, D.C. Okay, the Pentagon. Okay, but a pentagon doesn't have to be shaped like the Pentagon. It's called the Pentagon because it is a five-sided building. Okay, so prefix penta means five. Right? You're probably already familiar with the next one as well. What do we call a six-sided polygon? A six-sided polygon is a hexagon. Probably not a mystery on that one. The next one, there is a good bit of discussion about it, okay? And actually, some people have it memorized one of two ways, okay? But a seven-sided polygon, okay, while some people do call it a septagon, and if you look up the term septagon, you will find nothing wrong with that. However, most math textbooks and in our class, we are going to call it by its true name, which is a heptagon with an H. Okay, so hexagon and then heptagon. The next one, no great mystery. Everybody knows this. We see it a million times on our drive home every day. Okay, an eight-sided figure. Okay, eight-sided figure, of course, is called an octagon. Right. The next one is probably a little bit of a mystery as well. Probably haven't run across this one too much, but we do need to know its name. A nine-sided polygon. While you will find some people that want to try to call it a nineagon, that's not correct. It's actually called a nonagon with an O, nonagon. And then most people are familiar with the last specific name that we have for our polygons, and that is for 10 sides. And of course, a 10-sided polygon is called a decagon. Most people know this because of the term decade. Okay, decade is 10 years. Decagon is 10 sides. Now, after that, okay, we actually don't have many specific names that occur, okay, but there is a naming system that comes along after decagon. Okay, so we're going to have to know triangle through decagon. We'll have to know them and be able to call them by their names. Okay, but after you get past a 10-sided polygon, if n represents the number of sides in a polygon, okay, then what we do is we count the number of sides up in the polygon, whatever it may be, and we use the numerical number of sides and then attach gon to that. So in this case of the big block X here, we have a 12 gon. And the fancy little accordion looking guy over there, we have a 14 gon. And this is the way it works. So you got triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, but then you have 11 gon, 12 gon, 13 gon, 14 gon, and it goes upward like that. Okay, there are some specific names for some of these figures as you do go upwards, but the only ones we're responsible for is triangle through decagon, and then to know that we have the naming system. Okay, just a couple more definitions, and these go along with some of the stuff that we talked about yesterday on triangles. The term equilateral still applies for any polygon, not just a triangle. Okay, so any polygon that has all of its side lengths the same would be an equilateral polygon. So if it's four sides, then you say it is an equilateral quadrilateral, equilateral pentagon, equilateral decagon. Okay, so you probably just jot down that definition to make sure we have it. And then we also have the same for equiangular, just like we did with our triangles. Okay, so if a polygon were to have all of its angles the same, we'd say it's equiangular. We've already seen equiangular triangles. Okay, now we're seeing that that term applies for all polygons. Equiangular quadrilateral, equiangular hexagon, equiangular 37gon. It works for all of that. But there is one new definition. Okay, we've talked about equilateral and we've talked about equiangular, but something special happens when you are equilateral and equiangular at the same time. Okay, if a polygon were to be equilateral and equiangular at the same time, the word we use for that is regular. Okay, a regular polygon. Okay, so in these cases, okay, we would have a regular polygon because all the sides are the same and all the angles are the same at the same time. Same thing for the regular quadrilateral over on the right side. We're actually going to spend a good bit of time looking at regular polygons later on this year. As a matter of fact, test writers love to pick on regular polygons because there are so many properties that apply to a figure when they just pull out the word regular. Okay, that is all of the information for today. We'll see you in class on Wednesday, and I appreciate you finding time to do your notes.